दोस्तों जय हिंद जय भारत नमस्कार. In continuation with our physics classes, today we will discuss a most important point. It's a short discussion, but it's an important for the students. It is nothing but the Coulomb's law. How the Coulomb's law has been derived and how it has been defined in our physics. But before going to that Coulomb's law, let me explain what is the meaning of a point charge. We understood the charge in the last session. A neutron consists of protons and electrons, and protons consist of deficiency of electrons, and it has been declared as a positive charge, whereas the electrons consist of a negative charge. In continuation with the same, today we will try to derive the Coulomb's law. It's a very easy for the students to understand. But before going to that Coulomb's law, what I have mentioned, we will try to understand the point. How the point charge is been derived. I have a charged body. You can see the red one and the blue one. For the simplicity of the students, I have taken the two different color, but both are a same charged body. The distance is quite low between the two charged body. Please listen carefully, the students. The charged body have a distance, minimum distance. But if the distance is be increased linearly with the reduction in the linear area of the charged body. In the second case, the charged body linear area is been reduced. At the same time, distance is been increased. In the third case, again the linear area of the charged body is further reduced and the distance is been increased by the double. And again, third one and the fourth one, you can see in a sequential mode, the charged body linear area has been reduced, whereas the distance has been increased marginally between the two bodies. When the distance between the two charged body is been increased, when the size, the linear size of charged particle are too small compared to their distance. Please understood carefully, when the linear size of the charged particles are too small compared to their distance, that particular charged body has been declared as a point charge. Again, I will repeat, if the distance between the two charged body is quite marginal, in other way, the linear size of the charged particle are too small. You can see here from the top to bottom, the linear size has been reduced drastically, whereas the distance has been increased marginally. In that particular case, the bottom one point charge is been declared. The bottom one will call it's a point charge. Now let me go with the both charges. You can see the charge contains Q1 and the distance is been R is been increased drastically. This is a definition of the point charge. Now how will you derive the Coulomb's law? There are 2-point charge. Now no need to explain what is the point charge. There are 2-point charge consist of a Q1 and Q2 with a distance R. What is the force between the two charged particle? This is the question, and the solution is Coulomb's law. The simple question is, we have a two charged body with a distance R. What's supposed to be force between the two charged particles? Question: the force F, the force between the two charged particles, is directly proportional to the K, an arbitrary constant, multiplied by Q1 into Q2, the charge of the two charged body, and it is inversely proportional to the square of the distance. I will repeat, the force between the two charged particles will be, the K is an arbitrary constant. It's a multiplication of the charge consist Q1 and Q2 and divided by the square of the distance R. What a beautiful definition. By this formula, we can calculate the force between the two charged bodies. And the Coulomb's, the scientist has used the torsion balance meter to verify his formula. Mr. Coulomb has used torsional balance meter. I repeat again, Mr. Coulomb has used the torsional balance meter to verify this above calculation to find out the charge between, to find out the, the force between the two charge points. And Mr. Coulomb, how he has confirmed that his formula is correct. In first case, he vary the distance keeping the charge constant, and in second case he keep the distance same and vary the charge. And all this practical experiment Mr. Coulomb has confirmed that the force between the two charged particles is nothing but an arbitrary constant q1 multiplied by q2, and it has been inversely proportional to the square of the distance. This is the Coulomb's law. What's supposed to be an arbitrary constant value? It is nothing but 9 into 10 raised to 9. And let me verify this Coulomb's law in a different manner. I have a two charged particle with a Coulomb's with a value 1c, and I keep the distance 1 meter. The force must be 10 into 10 raised to 9 Newton. So what is the Coulomb's law? If we keep two charged particles having 1c charge at a distance of 1 meter, please listen carefully. I am explaining the Coulomb's law. If we keep two charged particles of 1c charge at a distance of 1 meter in vacuum, I give him a more emphasis on word vacuum. If we keep two charge of 1c charge at a distance of 1 meter, I have a two charge particle of 1c and I keep a distance of 1 meter in vacuum. The force will be 9 into 10 raised to 9 Newton. This is called a Coulomb's law. Please student, it is very easy to understand. If we keep two charge of 1c at a distance of 1 meter in vacuum, the force between the two charged particle will be 9 into 10 raised to 9 Newton, and this is called a Coulomb's law. What's supposed to be value of arbitrary k? K is nothing but 1 upon 2 pi nu 0. The Coulomb's 1c charge is too large for the calculation, and many times in your study in the further calculation you will find the electrostatic charge will be mentioned as a millicharge or microcharge also. So this is for your understanding. I have already said k is equal to 1 upon 4 pi nu 0. Force F, if we consider 1 upon 4 pi nu 0, q1 into q2 square of the distance. This is nothing but a mathematical formula for the Coulomb's law. Moving further, what is a value of permittivity? The E0 is nothing but the permittivity in a free space, and the value derived is 8.854 into 10 raised to minus 12 C2 Newton per meter square. This is a beautiful explanation of the Coulomb's law. I repeat, if we keep two charge of 1c at a distance of 1 meter, the force derived is nothing but a Coulomb's law. Thank you, Dhanyavad. We will meet soon with lecture 5, the force between two charged particles with a different angle and different distance. Thank you, Dhanyavad.